Hello friends, the topic for today's video is ATmega328P Pinout. The ATmega328P is a low power CMOS 8-bit microcontroller based on the AVR enhanced RISC architecture. The device has a lot of features. It is also most powerful of all AVR controllers as it is used in the Arduino boards. In today's video, we'll discuss the pinout and the pin description of ATmega328P. Let us start. Welcome to our channel Engineering and Technology for You. The topic for today is ATmega328P Pinout. Let us start with the introduction. The ATmel Pico Power ATmega328P is a low power CMOS 8-bit microcontroller based on the AVR enhanced RISC architecture. The high performance microchip Pico Power 8-bit AVR RISC based microcontroller combines 32 KB ISP flash memory with read while write capabilities. Then 1024 bytes or 1K EEPROM, then 2K SRAM and 23 general purpose IO lines, 32 general purpose working registers, 3 flexible timers counters with compare modes, internal and external interrupts. Then serial programmable UART, a byte oriented 2-wire serial interface. Then SPI serial port, then a 6-channel 10-bit A to D converter, 8 channels in TQFP and QFN MLF packages, programmable watchdog timer with internal oscillator and 5 software selectable power saving modes. So it is very much useful for saving the power. Then the device operates between 1.8 to 5.5 volts. Then by executing powerful instructions in a single clock cycle, the device achieves throughput approaching 1 MIPS per megahertz, balancing power consumption and the processing speed. So it is the most powerful of all AVR controllers as it is used in the Arduino boards. Let us start with the pin diagram. First, the configuration summary. Here the pin count is 28 or 32. It's available in 3 different packages. We'll see the details. Then flash memory is 32 KB. Then static RAM is 2K and electrically erasable PROM, that is programmable read-only memory, is 1K. Then general purpose IO lines are 23. Then this is the peripheral interface, serial peripheral interface. So that is, it has 2, and then TWR, 2-wire interface. This is I2C interface is 1. Then UART is 1. Then ADC, it is 10 bits, 15K SPS. Then it has got 8 ADC channels, 2 8-bit timer counters and 1 16-bit timer counters. Then let us go to the pin out of this IC. Now first we are talking about the pinout in PdiP, that is plastic dual line package. Here this figure shows the pinout of 28 pins. So it will have 14 pins on this side and 14 pins on this side. Now, as you can see, the pins, many of the pins are multiplexed with different functions. So this is the port C, PC0 to PC5, and then we have PC6 here on this side. Then this is port D, PD0 to PD4, then PD5, PD6 and PD7. Then we have the port B pins PB0, PB1, PB2, PB3, PB4, PB5 and PB6 and PB7 on this side. Then here we have the VCC and ground signals, and on this side we have the again the ground and the analog reference signal. So this pin diagram, so the yellow ones, they are for the power. Then this is the power signal for the ADC. Then black one is for the ground. Then these are the programming debug signals. They are shown in the blue color. You can see on this side. These are the pins. Then analog. So green are analog. Along with that, even some of them are combined with the digital signals. So ADC 0 to ADC 5, you can see here. Then other signals are also there. Then this is the crystal oscillator signal. So this is the pin layout for the 28 pin PdiP plastic dual inline package. Then let us move on to the next one, that is MLF. So this package, you can see the top view. Here again the package is 28 pin, and you can see the top view. Now the pins are starting from here 1 to 7, then 8 to 14, then 15 to 21, and then 22 to 28. Again the same colors are used here for showing the different types of signals. And this is the MicroLead frame package, MLF MicroLead frame package. So it will be very directly, you can put it on the PCB and the signals can be attached in a well manner. Now again the signals are multiplex. You can see the port signals are shown here, port C, port D, and on this side again port C signals, then ground reference, these are the ground and the VCC power signals are shown here. So this is another package. Then we have the pinout for 32 pin TQFP. So this is again another type of package, that is thin quad flat package, TQFP. So again it is very thin and it has now the 32 pins, so 8 on each of the side. This is the top view, and different signals, they are shown in different colors. Then the last type of package is 32 pin MLF package. That is again the same thing, that is the MicroLead frame package. MicroLead frame package. So again it will be very compact, and the different signals are shown in this. Now all these signals, though the IC is available in these 4 signals, so as per your requirement you can order the pins package. Now let us come to the pin description. Now here we'll go as per the port pins or pin numbers 1 to 28. So first pin is PC6, that is pin 6 of port C. Then again it has pin by default is used as reset pin. P6 can only be used as IO pin when reset is disabled. So reset disable view is programmed. So when we disable the reset, then only we can use it as a input output pin, PC6. Then next pin number 2 is PD0. It has again another function, that is RxD. So it is the pin 0 of port D. So and this RxD is data input pin for the UART serial interface. So USART is a serial communication interface. Then next pin is PD1. So that is for the TXD line, that is transmitter data output pin for the USART. Then again it is also used for the INT2, external interrupt to input. Then pin number 4 is PD2. Again it is used for INT0. So that is pin 2 of port D, external interrupt source 0. Then let us go to the next pin. That is pin number 5. So it is PD3, pin 3 of port D. Then alternate function is external interrupt source 1, INT1, and OC2B, that is PWM timer counter output compare match B output. So the timers, the compare mode is available in the timers. So compare match B output, so that will be used here. Then next pin number 6, PD4, XCK and T0. These are the alternate functions. So pin 4 of port D. So T0 is for timer 0 external counter input, and XCK, that is USART external clock. Then pin number 7 is VCC, that is connected to the positive voltage, and this pin number 8 is ground, connected to the ground. Then pin number 9, it is PB6, pin 6 of port B. Then alternate function is XTAL1, that is chip clock oscillator pin 1 or external clock input, and timer oscillator pin TOSC1. Then pin number 10, PB7. So again it is used for the chip clock oscillator pin 2 and timer oscillator clock pin 2. Then pin number 11, PD5, then pin 5 of port D. Then another function is timer external counter input. So here that will be another function of the pin. Then next function is OCOB, that is OC0B, that is PWM timer counter 0 output compare match out B output. So that is for matching the output, the timer. Then PD6, pin 6 of port D, it is used for analog comparator positive input. Then another function is OC0A, that is PWM timer counter 0 output compare match A output. So this is how it will be used. Then next pin number 13, PD7, port pin 7 of port D, analog comparator negative input. So these two inputs, it will compare the analog signal. Then PB0, pin 0 of port B, alternate function is ICP1, that is timer counter input capture pin. Then another function is clock 0, divided system clock. The divided system clock can be output on PB0 pin. So we can use it for our other peripherals which are in the system. Then PB1, that is pin 1 of port B. So it is alternate function is OC1A, that is timer counter output comparator match A output. Then pin number 16, PB2, pin 2 of port B. So that is for SS in SPI slave select input. This pin is low when the controller acts as a slave. Then serial peripheral interface. Here we'll have to use the SPI for the programming of that. Then another function is OC1B, timer counter 1 output compare match B. Very similar function as we have seen earlier. Then pin number 17, that is PB3, pin 3 of port B. So it is used for master out slave in, MOSI. When controller acts as a slave, the data is received by this pin. So these are the pins which are to be interfaced with the Arduino boards. So you can refer to my previous video on Arduino Nano Pinout. Then this OC2 is again timer counter output compare match output. Then this PB4 pin number 18, pin 4 of port B, MISO. This is master in slave out. When controller acts as a slave, the data is sent to the master by this controller through this pin. Then PB5, pin 5 of port B, again alternate function is, that is the serial clock. So in the SPI bus, this is used as a serial clock. This is the clock shared between the controller and other system for accurate data transfer. So when we are using the SPI bus, at that time we'll have a common clock and there will be one master and another slave. So these two lines along with this, they are used for the SPI interface. Then AVCC, that is the power for the internal ADC converter. And pin number 21, A reference, that is analog reference for ADC. Then 22 is ground. Then 23 is PC0, pin 0 port C, and again it is the ADC input channel 0. Then PC1, pin number 24, pin 1 of port C and ADC channel 1. Then pin number 25, PC2, ADC channel 2. Then pin number 26, PC3, ADC channel 3. Then pin number 27, PC4, that is pin 4 of port C and ADC channel 4, and then again it is used as a SDA, that is serial bus data input and output line. So that is the data line for the serial bus in case of the I2C, 2-wire serial. Then pin number 28 is PC5, again alternate function is ADC5, ADC input channel 5 and SCL, that is 2-wire serial bus clock line. So clock line and the data line, that will make the I2C interface, that is 2-wire interface. So these are the 28 pins of this IC ATmega328P. Then the references which I have used, these are the data sheets which are available online. You can refer to the data sheets for the details, and then as per your requirement you can choose the controller. So with this we come to the end of this video. If you like the video, please press the like button, share with your friends and subscribe to our channel Engineering and Technology for You, and press the bell icon if you want to get notified for my future videos. If you have any doubts, you can contact me on Facebook, Twitter, Gmail, Ulhaskumar Gokhale@gmail.com or Instagram. Then thanks for watching. Have a nice day.